Thank you so much for being here, everyone. My name is Sammy, my co-presenter is Bryce, and we're the representatives from the Data Science Discovery Project, helping educators use research evidence. We work with Dr. Valerie Shapiro, and our group advisor was Shruti. Our team members were Gabe, Hamza, Kaylee, Mallory, Prarthana, myself, Selena, and Shivali. So what is here? Our project focused on gaining insight into how K-12 teachers use the resources put forth by the state-funded initiative, Greater Good in Education. GGIE works to make research on teaching methods more accessible to K-12 teachers. The GGIE website provides free teaching materials based on research and with studies to back them up. When utilized, this research increases quality of education for students and for teachers. Understanding how it's accessed is vital. To gain insight into that question, we looked at 3 primary data sources. Firstly, we looked at SQL data from the GGIE website servers. We looked into what users commented on, the sentiment of those comments, and when they joined the website. Then, team members scraped Reddit and Twitter. This gave us insights into how social emotional learning and other GGIE buzzwords were being discussed on the internet. Finally, we looked at geospatial data, which allowed us to analyze where users were located.
All right, so I'll be describing some of the data that we ended up looking at, as well as some of the results that we gathered from our analysis. So we had one team focus our analysis on web analytics. So those were trying to figure out how the practices or resources on the website were being used by users, as well as how the GGIE website itself was appearing online through like Google searches. So for example, here we did some analysis on the keywords associated with different GGIE web pages to figure out what keywords are being focused on by different search engines and how we can optimize those to further GGIE's outreach, as well as some simple analysis on some of the ways that these resources were being used. Oh, looks like she disconnected. All right, let me try sharing from my side as well. All right. So next up, we also decided to go and look at web scraping data, as Sammy described before. And 2 of those resources that we used were both Twitter and Reddit. So for Twitter, what we tried to focus on was the GGIE social media account to see what type of outreach was occurring there. So we did some things such as sentiment analysis, as you can see here on this slide, as well as other resources such as how GGIE was being perceived on online. Additionally, we went ahead and looked at different Reddit analysis on what users perceived SEL to be and kind of their experiences with SEL, as well as maybe other GGIE topics as well. So we looked at comments and scores to see the different outreach of SEL, as well as trying to look for different sources that GGIE might appear on Reddit. And finally, we did some analysis on geospatial analysis. We actually got this data source pretty late, so we couldn't do much with it, but we did do an initial analysis on the distribution of GGIE users throughout California. And as you can see, there's a big proportion of users in San Bernardino County, which is where the project actually originated from. And we're planning on taking this, this analysis further by looking at different sources, the user distribution of people using the website. So this would include things like educational funding or maybe some trends with poverty rates, as well as the prevalence of SEL or wellness programs that may change based on the access to this website.
Right. The conclusions that we drew here can be used to design and perform A/B testing on the website. We have plans to do model distribution among the states with parameters like educational and wellness funding, poverty level and percentages, and mean education level to identify what impacts site access. And we're hoping to perform some market research with more detailed surveys to individual superintendents, principals, and teachers. The project also just gave, in general, a deeper understanding of how GGIE resources are utilized and accessed online by educators, the impacts of social media sites like Twitter on GGIE's outreach, and what user demographics are using GGIE resources and how these resources can help educators incorporate elements of SEL into their teaching. In conclusion, thank you all so much for being here, and we're happy to take any questions that you have.
Thank you so much, Rice and Sammy. That was really great work. I want to open the floor to the audience if you guys have any questions for them.
I just got to say, I don't have any specific questions. I appreciate your work. Thank you. I am glad to see a team working in the School of Social Welfare. I'm a PhD candidate in social welfare and had a data science team of my own this semester. And it's always nice to see people connecting data and interested in connecting data with social good and social welfare. So thanks for the work y'all did this semester on this project.
Absolutely, thank you.
I have a question for you. I'm a little curious. I thought it was interesting that you were able to drill down on San Bernardino County. And I was wondering about the ones where there was like no color in the counties. If you had a sense of why that might be, are they low population counties, or if any other kind of insights that you might have into why there was such a difference in the usage and the absence of using these resources. Yeah.
Well, I think one thing is that at least when we did get this data, I mean, it does make sense that the proportion of users would be in San Bernardino County, just because that's where like the project originated from. However, I do think that we are still trying to improve the outreach of the website as well. So we're, in a sense, I think, I'm not too sure when this website was created or when these resources started appearing, because I know that a lot of the goals of the website was to also focus their resources on like topics of teaching during coronavirus as well, or the pandemic. So it is possible. I do believe that we are like trying to figure, we're still kind of in the infancy of this research. We are still trying to figure out those type of trends, such as, maybe it might just be population, or it could be something more significant. Yeah,
Okay.
At least that's
Thanks.
my perspective is on, yeah.
Great. Are there any more questions?
I have a question about the website. Is that something that the students worked on in terms of, it looks like a lot of this analysis was done in either Python or R. Did you use, or what kind of methods did you use to migrate that or populate your website with your analysis?
So all the data from the website specifically came within SQL. So GGIE provided us with SQL dumps of the data on their website. So those included things like web analytics, collected through like SEO, Yoast, like data analysis, analytics, as well as other things such as some of the usage of the resources that are occurring on the website. So we didn't like personally actually create the resources on the website itself. Rather, we just were provided the data to do the research on it.
I see. Thanks.
And yeah, all our research was mostly done in Python. So.
Right. Thank you so much, Bryce and Sammy. My eyes are on the clock, so I'm sorry if I'm rushing and some questions are unanswered. But I would love to welcome the next team now, which is the Digital Humanities team. You guys have 5 minutes to present, and then we'll take some questions. Thank you.
Great. My name is Adam Anderson. I was the PI for the project Ancient World Citation Analysis that was going since 2019. And our 2021 team includes, or who are with us today, Kevin Gao and Peter Donovan, who both present on the components of their work. The premise of the project is essentially that libraries are, for the most part, inaccessible when you want to do discrete computational text analysis. And so the idea is that we're looking at ways of providing greater access at the archival level, like really like big data, for drawing different types of analysis and understanding the landscape of a given field of research. And we therefore are looking at building a better mousetrap in terms of optical character recognition, data mining and data labeling, parsing, as well as something more intuitive when we get to the machine learning and deep learning stages of embedded meanings of words and books in this larger context that most scholars refer to as genre. So we're looking at within a corpus of my own creation, one that's from the field of Near Eastern studies that includes linguistics and archaeology of the Middle East. And from there, we'll be looking at a few different workflows that we've built toward that end, starting with modeling NLP, natural language processing models.
Yeah, next slide. Yeah, so earlier on in the semester, we used a Python library called NetworkX to analyze an edge list or graph consisting of thousands of documents. Some things we explored were centrality measures, cliques, clustering models, and as you can tell by this slide, many visualizations using NetworkX in conjunction with Bokeh. On the left side here, we have a great example of that. You can see that there are two distinct groups in the graph. So the bottom left contains documents relating to archaeology and the top right to philology. And these two ends sort of push against each other, which helps to reveal the polarity in the field of study. Using visuals like these make it much easier to understand the relationships in a graph compared to something like reading a large table of text. Next slide. More recently, we've been developing a classification model to predict the topic of a document. So for example, given some 50-page paper, our model would analyze it and output whether it should be labeled as history, economics, archaeology, or so on. So far, our best model scores at roughly 91%, which means that if we feed it 10 random documents, it is likely to predict 9 of them correctly. And this is pretty good considering there are 10 topics to choose from and 1 correct answer.
I'd add here that we're looking at documents in many different languages as well. So this is multilingual, and it was built to be generalizable as well. So it's been really exciting working with Kevin on this. Next, we'll be looking at the language parsing that Peter will describe.
Great. So what Kevin just talked about was more the bag of words kinds of approaches where you look at the content of the text as a whole to build relationships between them. What I'm working on is kind of on a more basic level of extracting the structural information that's provided by citations. So what this means is, for example, if I want to extract information from this citation to find out something about the corpus, I would look for author surnames, I would look for the publication date, I would look for the title, and in this example, I've shown how I might find the title. So I look for a long string of words that's limited by periods, that's of the form of a few words, and then a colon, and then many other words. So that looks like a title. And so this information extraction process, you can see is pretty mechanical. There are these short little substrings, the period spaces, and so on, that it provide information about how the citation is structured. But the issue that makes this an interesting problem, at least for me, is that there are just so many special cases. There are so many special cases that even though it almost seems like you could read the style guides and hard code the patterns that the program is supposed to recognize, it doesn't quite work. And so what I've started to do is to automate the discovery of features, which means finding the common substrings that are not too highly correlated. They provide the same information as each other. And I'm trying to automate the discovery of the rules for which the rules about how the citations are structured, which for the moment just means that I'm using a random forest classifier. And so our use case is that we're trying to model these web of citations as a social network. So if our corpus is this black rectangle with the blue dots, then these, it's like I'm trying to find what these arrows are. So say the blue dot is a document that has an arrow, it's citing this bibliographic entity B that's purple. This is the connection that I'm trying to make. And if we find these directed arrows, we can use them to establish the relationships between our documents, so they're not just a jumble of PDFs in a folder.
Great. So far, this has yielded a number of different types of networks, and we use network analysis both for its statistical properties and proportions of the network, but also for a more interpretive visualization or graph in order to see the types of clustering and groupings that take place and the different types of relationships that are drawn over these documents. And our works in GitHub, as well as most of it's done in the Google Colab as well. It's been wonderful to collaborate with the students, and thank you both, Peter and Kevin, for your work this year.
I would say this is really impressive. I was like, the network, the figures and the graphs that you guys showed is just beautiful. I'm not sure how much of it I understand, but it's beautiful. So I would like to really invite someone who really understood those graphs to ask a question.
Well, I can't claim to understand the graphs, but I have more of a curiosity question for you. I know how hard it is to lay out those kinds of graphs. I'm curious in, what kinds of sort of tools were you using, and how much did you have to tweak each individual graph, or what kind of sort of smart stuff is going on behind the scenes to create some of those graphs? That's one question. And the other, I'm really curious, are you using sort of an n-gram kind of analysis with when you're looking at, and how big is n that you're using? And then my last question, I have three, is I'm curious about the looking at the structure of those references and pulling them apart. Is that something, you said that you can be really very systematic about it? Was that from a point of view of using regular expressions to try to put together systems to pull out different pieces? Anyway, too many questions probably, but.
That's great. Yeah, maybe I'll let Kevin start with the first one. If you'd like, Kevin, maybe just talk a little about the layout in Network X that you used, if you'd like.
Sorry, what was the question again?
So it had to do with the configuration of the graph, like how it's laid out when you show the polarity of these two different genres within the same field. You used Network X for that. Maybe I can just say, which is a really robust framework that's developed here at Berkeley. So the bids put on the GraphXD graph cross domains that actually featured Network X and the developers of that. So they're all BIDS researchers. And it is a really extensive framework library that has many different types of layouts. So the one we were showing is what's called a force-directed layout that uses the edges between the nodes to kind of push and pull these nodes apart so that you can then configure them in this way. But there are many different types of layouts and configurations that are really useful for interpreting the different properties of a model like this, because of course, the way in which it's configured has a lot to do with the way in which these things have been related to each other. So according to so for the second question, for example, so let's say you take a group of 100 documents and you use deep learning, like machine learning, like BERT, deep learning, Hugging Face architecture to find cosine similarity scores between your document. That'll take in 500 words, 512 words to be exact, into each embedded segment So that's the window for BERT, but of course it's smaller for like doc2vec, and it's only like a word to vec, but those are putting them into vectors. You could also do the same thing with different types of language models like n-grams or topic modeling, but then you'd end up with different relationships between the documents in the end. So then you'd end up with a different network graph, even though you have the same number of nodes. So all these are really insightful because, as it turns out, topic modeling is more indicative of genre, whereas word embedding is more indicative of context, like the actual context between documents. So if you're looking for like more embedded keyword searching, then you'd want to go more with like word embedding model. But if you wanted to see, again, like the kind of contours that you see in the library with the way libraries are organized, then topic modeling is really useful. So both of those will result in a different kind of configuration, but then you can play with the layout even to kind of make them look similar or dissimilar. So if you use, say, Frichter and Reingold, which kind of puts the network into a circle, then you could end up with, you know, something that looked really similar from one model to the next, even though the edges may be very different. So as for the parsing, I think Peter was nodding that regular expressions plays a big role in that, but I can let you field that if you'd like, Peter.
Yes, so I see we're a minute over, but yes, I have used regexes. It works, but it gets really hard. So if you know what the style guide is, it's still a little bit difficult, but you can do it. If you're working with like 10 style guides, then it gets harder. And if you have no idea what the style guide is, and you don't know how well people are following it, then it starts to become necessary to use a different approach, I've found. But if other people have other interesting things, then my mind is open.
Thank you, and apologies for asking too many questions and going over time.
No, thank you so much for all the great questions, and thanks, Adam, Peter, and Kevin, for all the great work. I would like to welcome our last team now, which is the Wall Street Journal team, to present. Sorry, Wall Street Journal. Yeah, sorry. I thought I said Wall Street team, so I said Wall Street Journal. So if you guys can, share your screen and start your presentation.
Yeah, of course. Thank you all for being here. My name is Vioma.
And my name is Kishore, and our project was on natural language processing in business journalism. And again, this project is in conjunction with the Wall Street Journal and the Data Science Discovery Program. And so the main challenge of this project was the inadequacy of out-of-the-box NLP tools to analyze business articles. And so some of our goals for the project were to build tools to help Wall Street Journal journalists do their jobs better. So, i.e. tracking what they're writing about and ensuring that there's a diverse set of topics they talk about. But so how do we do this? So we wanted to automate the process of searching through text for mentions of entities. And so what an entity is like, it could be a company, a person, etc. So like Microsoft or Bill Gates, anything of that sort. And so one method to accomplish this would be named entity recognition, which finds the entities in a given text and their types. So basically it will scan through a corpus and identify like Microsoft and then label it a company. And then we also want to help journalists understand the demographics of sources with the goal of diversifying. And so how we did this was through co-reference resolution, where we find all the expressions that refer to the same entity, so we can track exactly what we are talking about in each article and across articles. And so out of the box performance with these NLP methods was leaving something to be desired. So for example, named entity recognition using a basic spacey model. We see this since the S&P 500 report a spike of 500 points today. So it identifies 500 as a cardinal number and today as a date, but it's missing S&P 500, which would be important to track in a business article. And then for co-reference resolution, using the neural co-ref package by Hugging Face, we have the sentence, Tesla may also have other positive catalysts, including Tesla's expansion in China, which is likely to help support Tesla stock, Tesla ads. But this is actually an incorrect resolution of the sentence, because as we'll see later, it's supposed to say lithium product maker for the last two highlighted words, but it replaces it with Tesla, which is incorrect.
Yeah, so to address these problems, we spent the majority of the semester customizing these out-of-the-box models. And for named entity recognition in particular, this consisted of 4 steps. First, scraping the textual data and financial terms used for training. Second, annotating the entities that the out-of-the-box model normally catches that we want to keep catching, as well as annotating the new entities that the model currently doesn't catch. And third, removing the annotations that between those 2 sections that I just mentioned that are duplicates or overlapping. And finally, using the annotated data set to train the blank model. And over the course of this data collection and annotation and stuff that we'll mention later on in the presentation, we've come to see that there is a really immense need for annotated data sets due to the fact that journalism and many other fields outside of academia and like the tech industry don't have the resources to assemble them themselves. And so for the sake of time, we are going to skip the technical details, but we're happy to answer questions about those. And so the model, as you can see, improved pretty significantly after these changes. You can see that in the example provided, in the customized NER model, S&P 500 is recognized as an entity and correctly labeled as a stock index.
And yeah, to continue on, I'll talk about some of the ways in which we improve the co-reference model. So the basic methodology also involves scraping the training data first from Wall Street Journal articles. So gathering all of these articles and then labeling them manually with like the entities and whatnot. And then furthermore, once we have these articles and all of these entities, we can translate all of these annotations into a conversation dictionary. And what a conversation dictionary is basically what you can pass into a instance of like the neural co-reference model by Hugging Face. And this basically labels like rarer entities with something that understands better. So like it doesn't know what Microsoft is, but it knows what a company is. So you can label Microsoft with company and then it gets what's going on after that. And then we train this blank model using our conversation dictionary and the training data. And then as an example, here's what the final model is able to accomplish. So the original sense is the lithium product maker may also have other positive catalysts, including Tesla's expansion in China, which is likely to help support its stock it adds. But as we see in the sentence below, the output sentence, we see that all the its and it is replaced with the lithium product maker and the lithium product maker. So we're able to understand exactly what we're talking about in a particular sentence.
Great. So one of our stretch goals this semester was to analyze how companies talk about climate change in the documents that they present to investors. So basically, investors have started to become more interested in sustainable corporations and have begun demanding that companies take the problem of climate change more seriously. So our goal here was to determine which companies address climate change and especially which of them do so meaningfully with specific and actionable language that adequately considers the risks. And so far, we've scraped 10K filings, which are statements that companies are legally accountable towards, and parsed through those HTML files to extract the text content from the web page. We've also started looking into methods of selecting only the parts of the text that are related to climate change, but we still have a little bit to go there. And beyond that, the next steps would be analyzing these sections using a variety of techniques, including the tools that we customize at the beginning of this semester. And thank you all for listening to our presentation, and we're happy to answer any questions.
Thank you so much, Vyom and Kishore. I'm sure you guys have lots of questions, but we have exactly 2 minutes. So if anyone wants to jump right in and ask a question. Anyone? All right. In case we don't have any question, Vyom and Kishore, do you guys want to elaborate on any of the methodology that you couldn't go through?
Yeah, sure. Let me.
Oh, Adam, I see Adam has his hand up.
I have a question about the conversational dictionary you used for labeling it. How is that different from lemmatization? Isn't that similar in that you're kind of labeling certain types of words as something?
Could you repeat the second term you used?
Lemmatization.
Oh,
So we're
lemmatization?
yeah, lemmatization.
Okay, I actually have not heard of that term, so I
Oh,
won't be able
okay.
to answer your
Yeah,
question.
no
unfortunately.
worries. It's I guess another so instead of stemming, a lemmatizer will add every word to a kind of type of word in a dictionary. So it sounds like perhaps the difference might be that this conversational dictionary only selects certain words, like it doesn't
Yeah,
label every word as
yeah, exactly.
a type of word.
From my understanding, lemmas tend to be like more specific towards the word itself, whereas conversation dictionaries are broadly like this word is a company, for instance, and that sort of thing. I don't know if that's what you were asking though.
Yeah, thank you.
Right. Thank you so much. I think we barely have a few seconds left, but this was great. Thank you so much to everyone who put in so much hard work throughout the semester. And yeah, all the hard work has paid off. And I will see you guys in the main session now.